It's going to be hard to follow Marius' energy there. I didn't know that this was a comedy venue. I would have changed my presentation entirely had I known that this was going to be that kind of event. Oh, hey, here we go. Me llamo Gary Schulte. Yo trabajo para consensus en Besu, execution client. Saludos desde EthClient Summit. That's about all my Spanish. Let's go with that. I have a presentation for you on reactive scaling RPC with Besu fleet mode. When I ran through this yesterday, I was coming in a bit over 20 minutes, so I'm going to just kind of jump into this, and I might skip over or kind of drop some detail here so that I can get in under the 20-minute wire. And with that said, let's go. Why might you want to reactively scale RPC? I mean, you're probably an RPC provider if you want to reactively scale your services. You probably already know in that case that blockchain traffic is kind of peaky. You end up with airdrops and meme coins and liquidity farming and volatility-driven DeFi liquidations. All these things that kind of create this really peaky, clumpy traffic that you need to service. So an infrastructure provider is going to want to scale up to meet that demand so they can provide good quality of service. But also you're going to want to scale down in the lulls so you're not over-provisioned and wasting resources and wasting money. Unfortunately, Ethereum doesn't scale all that well in that way. I mean, an Ethereum node typically brings along with it terabytes of data. And if you're into reactive scaling, cloning terabytes of data is not exactly a fast thing to do. So enter Besu Fleet Mode. Besu Fleet Mode was introduced in December 2024, almost a year ago, in a blog post by Emily from Linea and Karim and Amizian from the Besu team. They did a great job on that blog post, kind of going into detail, talking about the history, the development, kind of the benefits and the trade-offs. I definitely highly recommend checking out that blog post if you're interested in reactive scaling. They did a great job, but in the interest of time, and so that we can kind of look at the results of the Linea pilot, I'm just going to kind of speed run some of the features. So let's do a quick recap of what about Besu makes this fleet mode feature possible. As always, the Bonsai storage format kind of features prominently in that it provides a flat state database. That flat state database sits next to your state tree, and it gives you kind of direct access to read and write state without having to walk the state tree. So you end up with really fast access. Additionally, Bonsai provides trilog diffs. So trilogs, if you're not aware, they're basically like a kind of a flattened block witness. If anything is touched, deployed, mutated, account storage, accounts themselves, they're going to be present in a trilog. In fact, you get a pre-image and a post-image of the block inside the trilog. That trilog is essentially how we roll the Besu state back and forth. The Bonsai state, there's only one state that sits on disk. So we roll that back and forth with those trilog diffs, incidentally. The next feature that we're leveraging from Besu, Marius alluded to the partial state history expiration. We have a blockchain pruner. It's configurable to either prune up to a certain height or prune a certain distance behind head. If you want to stay in protocol with DevP2P, and we all want to stay in protocol, right? You don't prune past the merge. I mean, unless you have a good reason to. And lastly, the Besu plugin API kind of makes this possible. We've been deconstructing the Besu code base for a while now and pulling out non-mainnet features and putting them into plugins and kind of keeping our code base really Ethereum core focused. So as we add new features that aren't core and as we pull old features out into plugins, this plugin API is kind of getting richer and richer and allows you to extend the client kind of any way, not any way you want, but in a number of ways to at runtime load a plugin and alter the behavior of the client. So speaking of plugins, Fleet Mode is a plugin. And it actually required very little changes to our plugin API in order to deliver its functionality. Speed running what those are. Fleet Mode adds some new RPC endpoints That's kind of bread and butter for the plugin API to extend Besu with new RPC. It introduces a new custom fleet mode sync behavior. We had to add like our synchronization pipeline hooks into the plugin API in order to accomplish that. It exposes state tree truncation. That's something that we had in Besu prior to fleet mode, but it wasn't something that was exposed in the plugin API. And then lastly, we added a trilog eventing system. So whenever you import a new trilog or execute a block, you can be notified of it, and you kind of react accordingly. So what makes fleet mode fleet? Our lovable Ethereum node over here with all of its state and blockchain. What we do to make fleet node fleet, the first thing is we drop state. If we restrict the fleet mode use cases to just read and write of state, we can get by with just, oh, is this a laser pointer? Can we use that? Yeah? No. We can get by with just a flat state. So we realize a lot of savings. I mean, the state tree is an order of magnitude larger than the flat state. So we get like essentially 80% of the storage of state back by dropping the state tree. In addition, we aggressively prune the blockchain. I think we just keep a handful of epochs of blockchain data behind head and aggressively prune the blockchain. The blockchain is like the biggest consumer of storage on an Ethereum node. So to aggressively prune that, you're getting hundreds of gigabytes back. So yeah, a lightweight node that has very little blockchain data and no state tree. It's as lean as it can be and still solve the use case for RPC. In fact, it's so lean, it can fit into system memory. Okay, so what is fleet mode? What does it provide? Fleet mode essentially defines a couple of new roles for an Ethereum node. It defines this role called a captain node, a captain role. And a captain is basically just a regular Ethereum node with a few new RPC endpoints. It still has a full state tree. It still has all the blockchain data. It's participating in P2P. It's directed by a consensus client. It's what you would expect an Ethereum node to be. But these new RPC endpoints are just some additional duties that it needs to take care of. Mainly, it provides an RPC endpoint to kind of register observers of its state. Whenever it executes a block or imports a new block, it's going to push out to its followers via RPC these new heads and these new trilogs, this new state that's occurred. And also, there's another RPC endpoint that allows you to kind of pull these trilogs via RPC for arbitrary block heights, block hashes, block numbers. So if you have an observer that gets this new head and it doesn't know about the intervening state between this new head and where its database is sitting, it can go and query its captain and say, hey, give me the block data, give me the state data, give me all the intervening changes. So it's basically, a captain is just a regular Ethereum node. The followers, though, are where the magic starts to happen. A follower node implements that state database format that I was talking about earlier. It's not participating in P2P. It's not participating in consensus. It's not directed by a consensus layer, I should say. It's designed to just serve RPC traffic. So like I mentioned, it doesn't have a state tree. It just has the flat state database. But with that flat state, you can still execute ETH call. You can do debug trace block. You do ETH get balance. Pretty much the entire ETH RPC namespace, with one notable exception of ETH get proof. If you don't have a state tree, you can't provide a Merkle proof. You can't calculate a new state root. That's just a trade-off that you're making with fleet mode. But if you're an infrastructure provider, you already have typically different node types in your setup. You've got archive nodes for historical queries, and you've got near-head nodes that are serving that kind of hot dynamic traffic. So if you're making that trade-off, you just kind of route any ETH get proof over to an archive node, and problem solved. Additionally, like I said, we're pruning that blockchain history, gaining all of that storage back. A pruned blockchain node and a dropped state tree, it results in a substantially smaller state. I think when I last checked, a mainnet Ethereum node RPC follower was about 80 gigabytes. and a Linea mainnet follower node was about 20 gigabytes. So in a typical RPC node and an infrastructure provider, that fits in memory pretty easily. So you get the benefits of much faster state access. So a follower node also is subscribing to its captains for state. Like I said, it doesn't have a consensus layer. It's not executing these blocks. It is, okay, 5 minutes. I'll speed it up. So it's not executing those blocks. It's just applying those diffs and moving quickly through the chain. It's querying trilogs from the captains to sync. And it's devoting all of its resources to RPC because it's not really doing the typical duties. There's no transaction pool it's maintaining, et cetera. Okay, so operationally, how do you get a stack of these together that's going to allow you to reactively scale? Well, first, you've got to start with a captain node. That is a typical Ethereum node. You need to sync it. You need to apply the plugin. We found in practice that a captain node can serve is about 300 follower nodes without really affecting the speed that it's importing blocks or the speed that it's disseminating those new heads. When you get a follower node, though, you need to sync that follower node from somewhere. You can do that with dev P2P like normally and then drop the state, or you could query the captain and get all the trilogs if they have all the trilogs since Genesis. Neither of those are particularly reactive. They're kind of slow. So the fastest way to spin up a follower node is to clone the database from another follower. Linea actually defined these source of truth follower nodes that their only job is to follow the chain head and then infrequently snapshot their database. So when you spin up a follower node with a snapshot, you then just sync up to head with the captain. And since you're just applying trilogs, it's super quick to sync up to head. The last element of the stack is an intelligent load balancer. You're looking at those queries as they come in. Make sure they're routed to an archive node if you need archive data. And if you're near head, hot traffic, route them to follower nodes. Okay, I'm going to skip past this since we are running out of time. And let's talk about an interesting moment, the 30 days surrounding the Linea token generation event. You can kind of see before the token generation event, we have this sort of kind of baseline looking traffic, coming in around 15,000 requests per minute. We end up with this little spike here in early September, another big spike here on the token generation day. This is all, if you notice, this is all EthCall dominated, all the traffic here. I mean, there's other RPC services, but EthCall is really dominant in that chart. On the token generation day, we get all of our Linea users claiming their airdrops, and we get this new kind of higher baseline of traffic, and then one more spike there on the 15th. So the way this scaled in production, you'll notice that these follower nodes, they're scaling on kind of a sawtooth pattern, and that's because they're using a continuous deployment strategy to kind of deploy this baseline level, and then on a schedule, they're scaled up to kind of meet the demand that they're anticipating. And then ahead of the token generation event, they kind of took those downscaler jobs out, and we have this static deployment. And then when we hit this big traffic spike on TGE day, we deployed a lot more follower nodes. The load balancers, they actually kind of more reflect the demand. They're kind of reacting just to the spikes like the one we saw on the 30th, the spike we saw on TGE day, and the spike we saw on the 15th. That's because they're using the Kubernetes auto-scaling instead of using a continuous deployment strategy and kind of on a schedule reactively scaling. Talking to the Linea ops, they're actually working on having these scale reactively with Kubernetes. I think there's a little infrastructure work that needs to happen before that can work. But yeah, it works really well. They scale up and down really quickly. We had some interesting learnings in the pilot, and that is, because we're running short on time, I'm just going to go quickly. The ability to load the database and memory, that was kind of discovered once we deployed the pilot. We didn't anticipate that. We knew we'd be able to scale quickly and we'd get better access, but we didn't expect to be able to fit all of that in memory. We found that we had a lot of pain points with our plugin packaging and configuration management. We added some build tooling, some prescriptive plugins to allow us to make that a little easier. We also found some RPC performance edge cases. I think the most notable is like really high gas ETH call usage. And that kind of gave us great feedback so that we can go through and fix that. We're working on that at the moment, actually. So the big reveal is during the pilot, the plugin was closed source. And as of today, the plugin is open source. So, hey. If you want to clone the repo, give it a try, set up your own reactive stack, give us a call. Check out the blog post for sure, because that gives great context. But contact us on Discord, on email. That slide's missing for some reason. There we go. Yeah. But again, me llamo Gary Schulte. If you have any questions, I can answer.
Excellent, Gary. I'll have you go to the center of the stage just for a second. We do have a few questions in there, and I think I'm going to sneak them in here if you bear with me here. So for the first one, can you share anything about space requirements, and in particular, what is the expected growth database size of the fleet node over time?
Well, it's really going to depend on the network you're talking about. Like mainnet, we notice is roughly a tenth. The flat database is roughly a tenth of the size, and that's pretty much where all of this the storage scaling is going to come from. So if you think about if your network has large state growth, you might end up with maybe a 10% of that in your fleet node database. So like a mainnet state is coming in around 800 gigabytes. A mainnet fleet's about 80.
Okay, and what is the time to sync?
When you are using a snapshot strategy, it's going to be commensurate on how old that snapshot is. But we find it takes less than 5 minutes to get any snapshot up to head.
Okay, and then one last maybe quick question. Can you talk a bit more about the flat state?
Yeah, so the flat state is really, it's kind of if you look at the Merkle tree state, the information you're looking for is actually in the leaves of the tree. So when you're walking the tree, you walk down the state tree to get to the leaf data that you're interested in reading or writing. If you have a flattened state, it's just the leaf data. You can access it directly by key, write it directly by key, and then worry about updating your state tree afterwards.
Excellent. So again, a round of applause here for Gary.